So, hi everyone. Today we are going to see the video about the simulation of symmetric inverter using Tanner EDA. So we will get into the video. First, we will use S-Edit for this simulation, which is given by Tanner EDA. So to design a circuit, first we need to create the library, then we need to add the libraries. Now in this video, we will be using SCL 180 nanometer PDK for designing the inverter. So first we will create a new library. We will create a new folder. Folder as inverter underscore symmetric. Okay. So now we need to add libraries. So libraries will be this PC, Intel graphics, DDA, process, standard libraries 160. Here we just need to click this devices, click OK, fine. Like that we need to add everything. Devices, then miscellaneous, OK, commands, search, okay, add library, plot, sources, fine. Now we need to add our SCL 180 nanometer PDK, so it will be TS018 underscore SCL underscore prime. Fine. Now it will load all the symbols like NMOS, PMOS, capacitors, everything. Yeah, fine. Now we need to create a cell. So go to cell, new view. Cell we need to add inverter. Fine. We maximize this. Press the home screen. Okay. Now what you have to do, select the devices, then press shift, then select the PS underscore 018 prime. Okay, then all the utilities it will show. Now select for NMOS underscore 18. Select this, drag this and drop here. Okay, fine. Now select, search for PMOS, drag and drop it here. Fine. Now select for, search for ground, select, drop it here. Now search for VDC, search, drop it here. Search for V pulse, which is a input which we will be giving to the inverter. And again search ground for this ground connection. Okay, now we use this wire tool to connect this drain, ground to source, and connect this gate to of PMOS to this gate of NMOS, and connect this body to the source of this PMOS, connect this positive of VDC to the source of this PMOS, connect this V pulse to the input of this gates. Then this is the connection of inverter. Now we have to take a output connection, select this output, drop it here. We want to keep it as out itself, so it's fine. Just click OK. Now we will be using 1.8 volt, 1.8. Fine, click enter, so it will change. For this we will keep this rise time as 10 nanos again, fall time as 10 nanos again, pulse period as 1U. Okay, fine. Now what we have to do for constructing a symmetric CMOS, we have to increase the size of this PMOS, because the mobility of PMOS is lesser than the mobility of N. Holes are much faster than, electrons are much faster than holes. So we have to increase this W value. Where is W? Yeah, here. We can keep this. Let's say we will keep this 1.46 times 1.65. Yeah. Now we will save this. Then we will go to setup sim. Then we will select the model libraries. So we will go here. We have to go to the desired library. So where it will be in my downloads. SCL model. Select this model file. Then select folder. Next, part 2 simulation result. Browse. You can select this. Okay. Then what you have to do? You have to click this setup sim. In general, you have to enable this as true. You have to enable this everything as true. Then now we are going to do one transient analysis. DC analysis. DC sweep analysis. Source or parameter where. Okay, first we would do the transient analysis. Then we would do one DC analysis. Where is transient? Yeah, here. Stop time is, we will simulate this for 20U. Maximum time step is 0.01U. Fine, that's it. Click on run simulation. We will wait, it will take some time. Yeah, now what we have to do, we have to go to SCL. You select this voltage, probe voltage, select this input, select this output. So here what happens, the input voltage is up to 5 volt, then the output which we are getting is only 1.8. Why? Because the input which we we didn't change the values, it's still 5. Now we will change this to 1.8. Now we save, now we run again. Yeah, now it became 1.8. If you select this, then the two graphs will split. Fine. When it is 1, it is 0. When it is 0, it is 1. So our inverter is working perfectly. So now we have to do one DC analysis to find whether this inverter is a symmetric inverter or not. Okay, so that what we have to do, we will remove this pulse source, select this pulse and click on delete. Now search for VDC, select, place this, click escape, click on this V2. In voltage we will select 1.8. Fine. Now we will save this, go to setup simulation. Now check off this transient and check this DC sweep analysis. Here we will give the source or parameter name as VV2 because we are going to change the input. VV2 start value 0, stop value 1.8, step or number of points is 0.01. That's it. Now we will do a run simulation. Okay, this is sweep requires linear. We have to click linear. Fine. Now select run simulation. Simulation complete. Here we have to select this voltage input and output. You will get this. This is the input which is changing from 0 to 1.8 and the output level is changing from, this is the output for output of the symmetric inverter. If you see, this input is cutting exactly at 900. Wait, let me draw this, draw a horizontal cursor bar. uh, for checking the symmetric of the inverter, we will draw horizontal and vertical line to the half of the VDD source. So our VDD is 1.8, so we will place it as 0.9. So here this is 0.909. What we can do, select this, then change here. Now you can change, now you can type 900 m. Then after that you can click anywhere, it will automatically go to 900. Again you can place a vertical cursor bar, click anywhere. For example, I am clicking here. Now select this vertical, go here, select 900 m. After clicking enter, click anywhere on the graph, it will automatically go to here. Now if you zoom it, it is not crossing exactly at 900 millivolt, but it's fine. We want 900 millivolt is here, but it is going before that, so we have to increase the, we have to increase or decrease the size of the width of the PMOS. So what we can do is we can do a parametric analysis to check whether we have whether we have to increase or decrease. So how we will do the parametric analysis? First, I know the value of the particular uh, symmetricity. So here W has to be, W is equal to 0.45. Here it is 1.625. I already simulated this value. Now if you try to do simulation, you will get the value we get the value exactly at 900 millivolt.